All right, we're going to do number 74. 74, we have a long, thin rod of mass M and length L. So it has a mass of M and a length of L. And it's standing straight up on a table. Its lower end rotates, so it's going to rotate around this point. So it's sitting on a table like this, and it's going to rotate around this point. A rotation point right there. A very slight push causes the rod to fall over. As it hits the table, what are the angular velocity and B, the speed of the tip of the rod? All right, so what's going to happen is it's going to fall over and it's going to just rotate like this. So it's going to fall, but this point is not going to move. It's just going to fall like that. So it's going to rotate over to this point right here. All right, how are we going to figure this out? Well, again, this is one that the only easy way to do it is use the energy. Okay, and we know the energy, it's all gravitational potential because you don't give it a shove, it just falls over. So this is gravitational potential, and it's going to become a rotation. 1/2 I omega squared. The key is we got to think about a few things here. What is H? Well, remember, H is not L. H always measures gravity, and gravity always acts at the center of mass. The center of mass is here. So H, this distance H, is actually L over 2. So this becomes mg L over 2. And then we look up I, and I for a long, thin rod rotating about a point on its end, which comes from that table on on page 300, is 1/3 ml squared times omega squared. All right, so now let's clean this up. The masses go away. This becomes G over 2, GL over 2, sorry, is equal to 1/2 times 1/3 is 1/6, L squared omega squared. Well, we can divide both sides by L. 1 L goes away. We're going to solve this for omega. So this becomes 6G over 2. L is equal to omega squared, or I'm just going to rewrite this. Omega is equal to, and 6 over 2 is 3, 3G over L. Square root of 3G over L. And there we go. We just solved part A. Notice omega only matters the length of the stick. The mass doesn't actually matter. Part B, we want to know the velocity of a point up here when it hits the, velocity right here, right before it hits. But we know V is equal to omega R. Okay? Well, V is equal to omega. Well, omega is equal to the square root of 3G over L. And R is equal to the radius of the rotation. Well, the radius of the rotation is equal to L. Now we can clean this up because we've got an L on the inside and the outside, so we can bring this L inside by squaring it. So this becomes 3G L squared over L. That cancels with that, and V is equal to the square root of 3G L. That is part B. And that's how you do number 74.